Hello, and welcome to the Consulting Specifying Engineer webcast, How to Design an Electrical Room with a Reduced Footprint, sponsored by Schneider Electric. I'm your moderator, Amara Rozgis, and I'm happy to join you today on behalf of Consulting Specifying Engineer and CFE Media and Technology. All right, so here are some details on how to get the most from today's event. If you're experiencing issues with your slides or with the audio, refresh your browser or click the Refresh Media button directly under the presenter's photo. You can control the volume of this webcast by adjusting it on your own device or by adjusting the volume on the webcast platform. If you're having technical problems with the audio or with the slide presentation, click on the question mark at the top right corner of your screen to access a list of things to try. If you do need a technician, please type your question in the Ask a Question box and the tech team will get to you as quickly as possible. Individual user experience questions will be answered in the Answered Questions box. Please type a question for the presenter in the Ask a Question box on the left side of the screen. The live Q&A session will start in about 45 minutes, and today's webcast is being recorded. So if you need to come back, you'll receive an email within about a week to the on-demand version of this webcast. To achieve your continuing education credit and to download a PDF copy of the presentation, use the Event Resources tab on the left side of the screen. Those documents will also be available with the on-demand version of this webcast. If you are interested in receiving that continuing education, there's an exam at the top of the screen. The link to the exam will open in a new browser window, so I suggest you open it right now. The link will break when this webcast ends. You'll also be able to access the link in the on-demand version of this webcast event. All right, well, I am now happy to introduce today's presenter, Brant Smith. Brant Smith is Schneider Electric's Power Systems e-mobility leader. He's been involved in power distribution since 1987 and has been an active IEEE member since 2002. Over that time, he's held various roles such as a journeyman maintenance electrician, instructor of electrical theory and equipment, application engineer, switchgear specialist, sales, business development, power system architect, and product application engineer, one of everything. He holds a BS in business, a BS in electrical engineering, technology, and an MBA. All right, Brant, take it away.
Thank you very much. I appreciate you all taking the time. I know everybody's busy. A few things I want to get out of the way before we get started talking about the continuing education credits. First of all, you do have to be registered on Schneider Electric's platform, and it has to be the same email address you're using for this event. If you're not registered, it's easy to do, and we'll include the link in the additional material as well as in the chat. If you're watching this as part of a group, each one of you needs to register for the event to get the credit. You also need to be logged into the webinar individually to get the credit. The platform itself, the My Schneider platform, is also a great resource for engineers, designers, and specifiers. It's a great place to go to get support. There's a community there, FAQs. There's also a lot of tools, everything from, for example, a library of CSI formatted specifications, design tools, for layout, calculators, and more. There's also a full library of technical information, bulletins for you to peruse and get the answers you need. There's also training on the site as well, the on-demand training, so that you can learn about the topics you want to learn. This is also where you're going to go if you want to download your certificates. So what are we going to be learning about today? First of all, you're going to be able to design with new technologies that will help reduce footprint. You're going to be able to describe how equipment orientation can affect footprint. You're going to be able to describe how to leverage different configurations, outdoor configurations to reduce footprint, and you're going to list alternative equipment that can be used to reduce footprint. So why is this important? The three main reasons, first and foremost is cost, flexibility, and then constraints. It makes sense. Price per square foot, it's not exact, but the smaller the building, the less the cost. It's not just in terms of absolute of materials that go into the construction. It's also lower cooling, lighting, cleaning, maintenance requirements. Heavy equipment, for example, if it's moved from the building, you can reduce the structural support requirements. And from a long-term point of view, a smaller footprint generally lends itself to lower cost. For example, if you have a full-size piece of equipment, it takes a larger access door. You may have to cut a hole through the wall to get to it. From a flexibility point of view, smaller equipment gives you more space for revenue-generating equipment. It allows you the ability to expand for future needs. For example, I had a customer who they had a set footprint in their electrical room. By using several pieces of equipment that reduced the footprint, they were able to leave space on either side for future expansion. And as far as constraints, the way I usually see this, we all run into issues on projects where we look up and say, for example, it may be that we're trying to fit something into a space where space just doesn't exist. An example of this, we had a customer that was renovating an old office building and turning it into high dollar downtown condos. The existing electrical room was not sufficient for the modern needs. If we had used metal clad switchgear, they would have had to blow out the wall of the electrical room and taken out one of their $1 million condos. Instead, we were able to fit greater electrical capacity into a smaller footprint and save them that revenue generating space. Once again, talking about cost, unless you're talking about something simple like a parking space, the dollar per square foot costs run anywhere from $200 to almost $1,000. The more complex, the higher revenue generating the space is, the more critical it is for us to minimize the usage for our electrical equipment and maximize the revenue generating space available. So we're going to start by talking about location. One of the easiest ways to save space inside a building is to move the equipment outside. And there's several advantages to doing this. First of all, by moving the equipment outside, we limit the impact on the air conditioning. We also are moving equipment that may have a personal hazard concerns outside the space itself. E-houses are one of the ways that we like to do this, especially in the heavy process industries. This is a very common tool we use. First of all, it allows us to focus that space and design the envelope, the e-house itself, to match what the equipment needs are to a very fine tune it. Generally about a 20% space savings. The other thing is we're able to use the air conditioning based on the electrical equipment needs, not based on the comfort of the occupants. So you can usually reduce your energy consumption. But the biggest advantage we see is that you are essentially building your electrical equipment room in parallel with your construction itself. Not only are you using a factory environment instead of doing it in a chaotic construction zone, where you have to worry about losing equipment or equipment getting damaged, you also are able to run a lot of your activities in parallel, which increases our time to bringing that project to market. We also like to move a lot of our large equipment outdoors, especially when we're talking about transformers. Once again, air conditioning loads, that's a major reason. You don't have as many requirements to support the equipment itself. And when you're talking about transformers, especially liquid filled transformers, removing the containment requirements from the building and putting it outdoors can have a big impact on your project. One thing I've been using for years is equipment orientation, especially when I was with e-house manufacturers. That was our bread and butter. How do we fit more into a smaller space? One of the tools I use all the time, and I have been for years, are modeling tools. Whether you're talking BIM, CAD, being able to lay out the equipment room and optimize the equipment layout is a huge deal. I know. I do this on my for my own personal use. For example, because of COVID, when we installed a home office, I used a CAD program to lay out my office to maximize the use of my space. And there's a lot of things we can do when optimizing space. There's a lot of tools in our toolbox. For example, back-to-back equipment, if you have front accessible equipment, removes the need for space behind it. One of the things I've done for years is sharing the working space. If you think about an equipment room, you have working space requirements. You also have code requirements for electrical clearances. Those are not additive. You can share that space. So by intelligently positioning your equipment, you can significantly reduce your equipment layout. Another area I like to use, and once again, this comes from heavily used in the e-house world, is moving the rear access for the equipment outside the building. This does create additional things that you have to consider. For example, you cannot install other equipment outside the building there. You have to be aware of weather when you're actually working on the equipment, but it eliminates the floor space from your building. Front accessible versus rear accessible equipment is another way that we can save space, and it's not a one size fits all solution. Sometimes front accessible is a space saver. At other times, it doesn't help at all. So my recommendation is, when in doubt, reach out to one of us, and we'd be glad to help you evaluate it. When you look at it, front accessible switchgear typically in and of itself has a larger footprint, but the big space savings advantage comes from working space. It comes from your rear accessibility. And by removing that, as you can see off to the far right column, it can have a significant impact on the equipment footprint. Another area we like to look at is, instead of using separate equipment, let's bring it together into a single piece of equipment or an integrated piece of equipment. A motor control center is a perfect example of this. If you look at the right, you see how many individual pieces of equipment, and if you imagine all of that having to be mounted to a wall, the amount of space it would take. And contrast that to the picture on the left of the motor control center, you can see how much savings, sometimes up to a 50%, space savings just by bringing it together. The other advantage is all of that interconnect wiring. This is all bus or internally wired, so it's done in a factory environment, which is generally a higher quality connection. Integrated electrical equipment, it's another way to save space. It's not just that it saves space, and sometimes it can actually save costs, but it's also what it does for the aesthetics of the installation. I want you to think about, see the two pallets in the middle of equipment arriving into a job site. First of all, trying to keep track of it and managing that and installing it correctly can be chaotic. And then you have a wall of electrical equipment. Oftentimes are trying to lift heavy transformers, which at their heart are nothing more than copper and steel, into the overhead to hang from the ceiling. And you contrast that to the picture on the left, where it's one cohesive, attractive installation. A couple examples, and these are from real life. If you look at the top one, and the all of the the stacked transformers and all of the busy layout, and you contrast that to the picture on the right where it's a much cleaner installation. In this case, the material cost was actually there was a minor savings, but the big savings came in the labor hours, where we saved almost 100 hours on that installation. Same situation on the bottom. It's a very chaotic installation, and you contrast that to the nice, clean, integrated equipment where, once again, over 100 labor hours saved on that installation. So just by using integrated electrical equipment, not only are you saving space, there's usually a cost savings when you look at the labor. And to me, especially on a large project where you have, for example, a automotive manufacturer that I'm working with, where they have millions of dollars of panels and switchboards being delivered to the job site, and trying to keep track of it and doing the installation correctly, and you transition that into an integrated piece of equipment, the savings for them and the ability to manage that project, is a profound benefit. Busway is another area where we can save space as well as labor. If you think about it, instead of running individual conduit and cables, or going through cable tray to the loads, if you can run a line of busway and use bus plugs to drop off for each individual load, it's usually a faster labor saving type of installation. And it can also result in space savings over having to try to coordinate where the cable tray runs, conduit runs, and conflicting with things like your air conditioning ducting. So another area that we look at is, can we use compact equipment? There's a lot of equipment that has a significantly reduced footprint, and I'm going to take a step back here and say, and put a caveat in here. Smaller is not always better. In general, some of these solutions are a significantly better solution over the larger full, for example, gas insulated switchgear over metal clad. However, there are times that you have to take into consideration space for, how the incoming cables are coming in, space for your CTs, your metering, your wireways. I also like to, having been hands-on early in my career, I like to look at it from the point of view of the guy that's going to have to work on the equipment 5 years down the road. I like, I'm a big fan of our small footprint fusible disconnect switches, and it can be a great way to fit additional capacity into a small space. But I also like to think about, the 275-pound electrician whose pinky is as big around as my wrist, and having to fit into a 14.75-inch sheet metal enclosure, trying to work on the equipment, where if the space is available, let's give that guy an extra foot of space to work in. One of my favorite tools that I've been using for years is gas insulated switchgear. It's a great solution at 27 and 35 kV. Since it goes up to 2,500 amps, 40K fault current, this is the solution, especially when you're thinking 35 kV, that is a lot of power that is being put out through that switchgear. There are several main advantages to using gas insulated switchgear over metal clad switchgear. First of all is reduced costs. Gas insulated switchgear is typically more cost effective than metal clad switchgear. It has a significantly smaller footprint. To put this in perspective, at 35 kV, your metal clad switchgear is going to be roughly 4 foot wide by 10 foot deep, single high construction. Your gas insulated switchgear is going to be a quarter of the footprint. Now, I had a application probably 15 years ago where we took a 4-way split E-house, so essentially 4 separate E-houses bolted together design with metal-clad switchgear, and by shifting it to gas-insulated switchgear, we were able to reduce it to a single shippable section. It was a significant cost savings. Probably even more importantly is that the customer was trying to figure out where they were going to put this equipment for their expansion, and it made it much easier to fit it into their facility. Another advantage of gas-insulated switchgear, it's a safer product. The failure points have been engineered out of the switchgear. Over 50% of the failure points in metal-clad switchgear do not exist in gas-insulated switchgear, and it is virtually impossible to have an arc flash. It's touch safe. It's a safer product for our people. And it's also more reliable since most of the critical moving components are not exposed to the environment. So taking just a typical one main breaker, 4 feeder, line up a 35 kV switchgear. If you look at metal-clad switchgear to gas-insulated switchgear, it is roughly 1/4 of the footprint. It is a profound space savings, and while it doesn't fit in every application, when we can use gas-insulated switchgear, it is usually a safer, more reliable, better product at a better price. So lots of advantages for our customers to design around that technology. And I'd love to talk more about it. As you can tell, it's a area that I love, but that's an hour-long topic in and of itself. A similar solution, but at 15 and 5 kV, is solid shielded insulated switchgear, which we're just going to call 2SIS to be brief with it. A similar concept where with gas insulated switchgear, you use SF6 as your dielectric, which allows you to reduce the space between conductors and reduce your footprint. 2SIS uses epoxy to get the same effect. It gives us a significantly smaller piece of equipment. It gives us a safer product because it is touch safe, and just like gas insulated switchgear, virtually every form of arc flash is eliminated. And I will say though, it's not the right application for everything. It goes up to 1200 amps, 25 kA, and 95 kV BIL. That is about 80% of our applications. I see a whole lot of 40 kA switchgear specified that when you actually look at the fault current, it's below 20. But when it fits, it can have be a great product to support our customers. Like I said, it's epoxy insulated, and it has a grounded layer on the outside, so it's incidentally touch safe, and it's very similar to what you get with a medium voltage cable. You have an epoxy, you have an insulation with a shield on the outside. And from a space savings point of view, as you can see, it reduces the footprint by roughly 50%. By the way, this is the product that we used in that application I talked about earlier, where they were going to have to blow out the room in the the wall in the electrical room, and take out one of their $1 million condos. This is the product that allowed them to fit into that space. There's also reduced with metal-clad switchgear. This is full metal-clad switchgear. It has a withdrawable circuit breaker. It has all of the insulated bus. It has the compartmentalization. The difference is instead of being 3 foot wide, it's 26-inch wide sections. So it has a pretty significant footprint savings. The other advantage is, at least with our 26-inch wide product, is that it is our next generation switchgear. So all of the new technology and the path forward is in this platform. And when you're looking at, especially with switchboards, using high density metering can be a game changer when it comes to space savings. I want you to think about a switchboard and trying to put a separate meter on each and every one of those feeders, versus being able to put CTs on the individual cables and come into a single meter. Also, we have the ability to integrate a lot of functionality into the devices. If you look at the protective relays, we have had for years. It essentially is a PLC in addition to a protective relay. So we have the ability to move a lot of the controls and a lot of the automation into the device itself, not only saving the cost of additional equipment needing to be installed, but also sometimes all the extra equipment drives up space. Our newer circuit breakers also have a lot more capability built into them, and depending on the needs for metering accuracy, a lot of times you can drive basic metering into a protective relay or a trip unit. And in some cases, for example, with our new line of low voltage breakers, we have 1% accuracy with our trip unit. That's a big advantage, and it's not going to fit in every application, but if you can eliminate a power meter, that can not only save costs in the project, but also sometimes that extra meter takes up additional space, and you may find yourself bumping into an extra section to fit it. And when it comes to our data centers, there's a lot of new technologies coming out that can save space. One of the newer technologies is liquid cooling. Instead of letting the heat hit the air and then using air conditioning to cool it, let's go directly to the source and use liquid cooling to remove the heat. It can have a smaller footprint in the data center itself, but it also has a huge impact on the system because you need less cooling equipment, and all of that cooling equipment takes space. All of the switchgear to feed that cooling equipment takes space. So this can have a big impact on our ability to on our electrical installations. And then we're going to move on, and we kind of lumped it together to architecture, but to me, this is how do we design our system? What are we thinking about, or what are we doing? The first thing we can do, as engineers, we have a tendency to want to build redundancy into everything. We want to engineer it to be as reliable as physically possible and think about every possible contingency in the future. But a lot of times, not only does that add cost, that adds space. And an example of that is oversizing your CPTs. It's looking at things like using smaller breaker frame sizes. I have one customer that they use the maximum breaker frame size, and they want that for every single breaker, and they'll just dial it down. The problem is you've just to get the same number of breakers in that switchboard, you've just significantly increased your footprint. If you also looking at things like top entry versus bottom entry, are you utilizing all of your top and bottom conduit spaces? There's a lot of things that we can do to intelligently design our systems and still design reliable systems, but not add additional sections to make it happen. One of the big things is switchgear versus switchboards versus panel boards. It's a very common thing, especially in industrial applications, to see people try to move up a class in equipment, and there's an impact not only on cost but also on the footprint of the equipment itself. For example, if instead of using metal clad low voltage switchgear, can we take that down to a switchboard? If we can move that down to a switchboard, there is a significant cost savings and a significant space savings as well. And in some cases, you really don't gain much for your electrical system by moving up into the higher rated equipment. Another area to look at, do we really need individually mounted mains? And there's sometimes you have to do that, but if you can eliminate that and just backfeed a main circuit breaker, you can save an entire section just on the main. And with automatic transfer switches, this is another area where we can say, now there are times, this is also an area where we have to think about the system. Are we paralleling with a generator? In that case, a circuit breaker is a better application. There's times that the larger circuit breaker style ATS is the right solution, but there's also times where it really doesn't make a difference, and the smaller contactor is better for the customer in their installation. And the other thing, especially in this world where we are pushing more and more data out of our equipment, not just out of things like our protective relays and our trip units, but we also now have the ability, for example, to put temperature sensors on our bolted connections. And if you think about a lineup of switchgear, your main failure point is either going to be your bolted bus connections, your cable connections. We can put temperature sensors that continuously monitor that 24/7 and watch for temperature rises to warn us of a potential problem before we actually have it. But all those additional devices, integrating all of that equipment, for example, remote operability. If you have to, hardwire a remote operability panel, that all takes space and adds complexity to the system. Where, for example, newer equipment, our newer breakers and our newer trip units have the ability to access that device point to point so that it's secure, but we have the ability to use Bluetooth to access that device and move the operator away from the equipment when he's looking at it without the additional wiring installed. And arc flash is another area where, if we're not careful, we can significantly add space as well as cost. Now, I will say that arc flash, and we do have a seminar on our website. It's I believe it's a 4-part seminar that goes in depth into arc flash. It is a bigger question than just footprint, costs, or a preferred method. But how you choose to solve arc flash can have a big impact on your electrical system. Avoidance is typically a minimal impact one, although it depends on if some companies to avoid arc flash when their people are working there on their equipment go with a main type concept so they can de-energize a part of their equipment. The problem is you now have redundancy in your breakers, so you can feed them from other sources, and you also have the additional breakers for your main and your tie. It adds reliability. It also gives you the ability to de-energize a good portion of your electrical system so that you can work on the equipment, but that comes at a cost, a higher cost to the customer and a higher cost in space. Prevention is usually minimal impact on footprint, with the exception of gas insulated switchgear and 2SIS switchgear. In those cases, they do prevent arc flash. And as a result, you end up with a smaller footprint, and usually it's at a lower cost to install it. Containment's an area that adds to the footprint. And if you think about arc venting switchgear, it makes sense. If you have a more robust enclosure, and then you throw in all of the ductwork that's required for that, it just adds a lot of space. And reduction technology sometimes can impact it. For example, your high-speed switches, your shorting type switches, that adds additional space. It has a big impact on footprint. Going to current limiting fuses can have an impact on it. So we just think the message isn't don't do it. The message is let's take a step back. Let's look at arc flash from a higher 10,000 foot perspective, and maybe the answer is to use several technologies and layer passive and active technologies into it so that we protect our people, but we don't drive up project costs, complexity, and increase the footprint. Harmonics mitigation is another area where we need to look at it from a 10,000 foot view. If all you have is a couple VFDs in the system, it's probably the simplest way to do it is use filters. Go to the source, make it easy. But if you have for example, a motor control center full of variable frequency drives, or multiple sources driving it, a lot of times it makes more sense to go to a system-wide harmonic filtration approach. The individual piece of equipment may have a footprint that impact on its own, but it's a lot less than the overall footprint impact of individual filters. Once again, this is a topic that goes well beyond it, and it's a great opportunity to step back and say, how can we design this system better? And then there's the side of it. A friend of mine liked to describe it as working in a Starbucks. He loved working in the Starbucks. He hated the fact that he was bumping elbows with everybody, but the access to the restroom, the environment, the ability to get a good cup of coffee and or a snack, it was worth it for him. And so we kind of run into that when we talk about footprint, because sometimes, for example, small footprint fusible disconnect switches, there may be a lack of utility down the road when the technician has to work on it. However, it allows us to fit a great deal more capacity into a small space, and at the time it makes sense, and it's a great thing for us to be support, for us to install it. So sometimes it makes sense and sometimes it doesn't. So in summary, what do we want to take away from this? First of all, why is this important? First of all, it's important to reduce footprint because there's a significant cost savings for our customers. So there's a cost savings in maintaining that environment, whether it's air conditioning or actual maintenance itself. There's a cost of the installation and building it. It gives us greater flexibility, and a lot of times a small footprint piece of equipment gives us the ability to work around issues in a site. We're able to, for example, when I was talking about the gas insulated switchgear application, instead of a 200 foot by 25 foot by 50 foot wide 4 split building, we were able to move it down to a 70 by 20 22 foot wide single shippable building. And especially since with like e-houses, it's price per square foot, there was a cost savings, but the big advantage was they didn't know where they were going to put this equipment on their site. They didn't have space. The moving the equipment out, we do that all the time with NEMA 3R equipment, but we can also get creative. We can use an e-house and move equipment that wouldn't traditionally be moved out of and move the entire electrical room outside of the building. There's a lot we can do with orientation, and I know we have a lot of people on our staff that this is one of the things we do all the time with our consultants is we sit down, we talk about the equipment, we talk about specifications, but we also look the equipment orientation and the layout and figure out how we can do it more efficiently. We help our customers with that. The use of compact equipment, in most cases, it makes sense. In some cases, it may not. We need to look at it, but that can be not just a cost savings, but also a huge footprint savings. And then not over engineering our systems. If we use a switchboard instead of switchgear when appropriate, if we don't oversize our circuit breakers, we can put ourselves put our customers in a better position. Now we've thrown a lot at you today. I know that. This will be available, and you can click on any of these links for additional information. You can go to our website and ask questions there, or you can reach out to your Schneider representative, and we would be glad to talk to you about any of this, whether it's, gas insulated switchgear, solid insulated switchgear, or any of the other technologies. That's what they're there for.
All right. Well, this is where I help out, Brant. Thank you so much. That was a ton of information. I do appreciate it. And now Brant will answer questions from the audience. Please type your question into the Ask a Question box on your screen, and we will get to as many questions as time allows. Questions that we do not get to today will be posted online at www.csemag.com. And remember to download instructions for achieving your continuing education, or a copy of this presentation and all those references and resources. Use the Event Resources tab on the left side of your screen. All right, Brant, like I said, we do have a lot of questions, so let's tackle the first one right away. How much more is GIS, that's gas insulated switchgear equipment, how much more expensive is it than AIS? And then two-part question, on a project lifetime cost comparison, does GIS score better?
And actually, the gas insulated switchgear, especially at 35 kV, typically costs less. Even at 27 kV, it's very attractive. Most people's 27 kV switchgear is based on 35 kV class switchgear. So the cost itself for the equipment, it just, it's a better cost. There's other advantages of it as well, beyond the safety, the reliability, and the footprint. I know in these crazy supply chain days that we're dealing with right now, I've never seen the likes of this before. This is insane. We can get gas insulated switchgear delivered far quicker than we can metal clad switchgear. Now, what was the second part of the question?
Yeah, so this is over the lifetime of the project. Which one scores better price-wise?
The gas insulated switchgear. It depends on the technology you use. Some of the older technologies have, I call it plumbing. It looks like, bolted together flanged plumbing. In that case, you have to worry about, SF6 leakage because you have all those leakage points. The more modern design, everything's sealed at the factory. So, from an SF6 point of view, you don't have to worry about any maintenance. The other thing is all of your moving components, the majority of that is inside the enclosure itself, inside that gas compartment. So it's not exposed to the environment. It's lubricated for life, vibration proof fasteners. It's designed so that you don't maintain it. Now, I know some people like to say it's maintenance free. That's not entirely true. And there are things you have to do. You have to look at it on a periodic basis, make sure that structurally it's fine, make sure that somebody hasn't run a forklift into it. And by the way, I've seen somebody run forklift into switchgear. You have to, it's not a bad thing to examine the mechanism on a periodic basis, but it's significantly less than metal clad switchgear. And the other thing is there's just fewer failure points with it. So from a fixing something that's not working point of view, it just costs less.
All right, awesome. Thank you very much, Brant. This next question. So we're talking about the industry as a whole, and then if you could narrow it down to what Schneider Electric is doing, what are you doing to replace SF6 gas with environmentally friendly solutions? So start with the industry and then narrow it down specifically to Schneider Electric.
As an industry and as Schneider Electric, we are moving away from SF6. Having said that, this is a challenge because SF6 is a unique gas that has, it does things for your electrical system that are very hard to repeat with anything else. Now, having said that, we are in the process of, and it's not here today, but it's coming over the next few years of gas-free switchgear. And everybody in the industry is moving that way as well. There's a couple people that are using other gases, but those other gases honestly, they have as many problems, in some cases are worse than SF6. SF6, it may be a greenhouse gas, but it's the wimpiest greenhouse gas I've ever seen.
Okay, excellent. Good to know. And this is a follow-up question for you. So are we talking about the Schneider Electric products not using SF6, or how does that all come together?
We are moving away from products that use SF6. So for example, our gas insulated switchgear is, we have a design, we're testing it. It's first being applied in Europe, and then it's going to come into the United States, where we can accomplish the similar footprint, similar advantages, but without having SF6 gas. It takes time to get there.
Okay. Next question is a very basic clarification question. What is an e-house?
I apologize. You are not supposed to use acronyms and things like this. An e-house is a prefabricated metal building. It's usually built in a factory, and most of the time, all of the electrical equipment that is going to go into the e-house itself are installed in the e-house. They're tested. The interconnect wiring is done. So I would love to say that it's plug and play, but I mean, it's a little more complicated than that. But the idea is it's shipped to the site, it's set in place, you run your incoming and outgoing cables, do your final test, and your installation's done.
Okay, got it. So let's talk about labor, floor space, all that kind of stuff. What's the savings there?
From a floor space point of view, what you really get is an e-house is usually highly optimized for the equipment that's going in it. For example, if you have, medium voltage switchgear direct connected to medium voltage motor control, instead of going off frontal lined, usually you go off rear aligned, and then that allows us to put other equipment across from the motor control and really shrink that footprint down. So from a footprint point of view, I can usually save quite a bit on using an e-house. The biggest advantages with an e-house, and once again, this is not an e-house conversation here entirely, but with an e-house, first of all, you usually have tax advantages because it has different depreciation than site-built, stick-built buildings. The other thing is, when you set it on site and you've done all of that labor, instead of doing equipment installation in a muddy, chaotic construction site, you're now doing that in a controlled factory manner. The equipment is checked in and checked out. There's quality control, and it's installed by people that are experts at that equipment. Not all electrical contractors, for example, are experienced installing metal clad switchgear, where the people doing it at the house are going to be.
All right, thanks for that explanation. The next question for you: can you give an example of when front accessible equipment would take up more space than rear accessible equipment?
Oh, absolutely. If you are going to have, if for example, you're able to push the rear accessible equipment up against the wall and you have rear access panels, you're going to use less space. The front accessible switchgear in and of itself has a larger footprint. So the time it makes sense to use it is when you can push it up against the wall and gain that rear access space otherwise. But if you're going to put it in the middle of a room, you might as well use rear accessible. If you're going to have rear access to it, you should just use rear accessible.
Okay. So this is kind of a follow-up question. What are some best practices or tips for finding the delicate balance between a small footprint and a comfortable working environment?
It depends on the equipment itself. If you know, I like using the fusible disconnect switches because we can really fit a lot of capacity into a very small footprint, but that is not a comfortable to maintain footprint. Now, let's face it, you're not going to be going into that equipment on a regular basis. This is an occasional thing, but still, having I use the example of, the site electrician. It's not usually, it's not usually somebody that can fit into a something that's just barely over a foot wide to work on it. Let's go with a double wide section. That is a significantly easier piece of equipment to work on. When you look at things like gas insulated switchgear or solid insulated switchgear, you don't have that problem. Especially if it's bottom entry, all of your access is from the front. Anything that like a trip coil that's going to need to be replaced is easily accessible on the front behind the front cover. The cable connections are convenient and at the front, and it's the type of connection we use in pad mount switchgear. So it's all, it doesn't lose you anything to use that compact footprint. It's not, you don't lose any comfort on it long term.
Right. Okay, makes sense. Thank you. Next question, kind of sort of related. Recommendations or suggestions when designing electrical closets?
Depends on the closet, how much space and what you're trying to fit in there. When possible, especially if we're trying to put a lot of equipment up against the wall, I like using integrated designs, or our IPACs, because or IPC2, because it puts everything in a nice tight package. It eliminates that chaos of nothing but a wall of panels and unistrut, and it usually saves space and installation costs as well. But that also depends on what that space looks like and where you're going to put the equipment.
Right. Yeah, I think it depends is probably the best answer for most of these.
And a lot quicker than what I said.
Yeah. All right. Next question for you. Does the integrated power distribution assembly allow for modifications and equipment size increases?
It's a very flexible platform. Usually, we very commonly see it with a 40-volt switchboard, a transformer, and a panel board, and that's a pretty common configuration. But we also have the ability to integrate lighting controls, HVAC controls, and it's very flexible. It is possible that it might take up more space, but in most cases, because of how you're putting it together, it's just a significantly it's a significantly cleaner installation and usually takes up less space. What I like to say is you have to evaluate. You have to look at it from a 10,000-foot view and see what's going to actually be on an individual case. There's very few times that it's a definitive, it will take less space than this.
Sure. Okay, so let's talk about technologies adding complexity. Is there a complexity added to the system by adding these technologies, or what does it really change?
It depends on the technology and what you're trying to accomplish. In some cases, that technology is already there. The difference is we aren't accessing it and sending it anywhere else. If you add something like continuous thermal monitoring, you are adding some complexity to the system. There's additional components. You have to bring the Zigbee signals in. You have to go to an HMI. You may want to integrate it to something else. But at the same time, that additional complexity can also give you a great deal more functionality. And if you think about a failure point in your equipment, your failure point is most likely going to be the incoming cable connection, possibly a bolted bus connection. and the consequences of that failure far outweigh any additional complexity. Now, having said that, we all like the shiny object, and I know people try to push it in. In reality, I like to go with the simplest solution we can, because at the end of the day, the simplest solution is usually the most reliable.
Yeah, it is. All right, next question for you, Brant. And I wanted to say, if you do have a question for Brant, feel free to type it in. If we do not get to it here verbally, we will answer as many questions as possible in writing. So let's see here, Brant, another question for you. Can we get a transformer with integrated primary disconnect and secondary overcurrent protection?
I would have to get back to you on that one. Sure. I don't have the answer off the top of my head on that one.
All right, we'll come back to that. Thank you. The next question for you, this is another clarification question. Please clarify what is meant by a back-fed main breaker.
A back-fed main breaker, instead of having the main breaker separate from the switchboard, it is one of the breakers in the switchboard itself, and you're feeding the switchboard through that main breaker.
Okay. All right. So here's another question very specific to California. We're talking OSHPD here. Are the gas insulated system and 2SIS, have they been used? Are they authorized through OSHPD? Are they, what projects are they in right now? Any?
I would have to double check on that to make sure, but I believe so. We're installing both of them, and we have significant installations in data centers and industrial facilities around the country. So I would think so, but I don't know definitively.
All right, we'll come back to that one. All right, a little bit about lead time. Is there a difference in lead time for integrated equipment versus individual panels or transformers?
There is a little bit of a difference in lead time. If you think about the integrated equipment, it is integrating all of those things, the panels, the transformers, into the equipment itself. So there is time to actually do the integration. But the same lead time constraints we run into with everything else, it drives it into the integrated equipment too.
Okay. All right. Well, Brant, we have time for only one more question. So this one's tough. So let's talk about hot weather. What is a realistic maximum summer temperature for things like transformers? Because we all know that different parts of the United States are seeing extreme temperatures.
Honestly, I hate seeing, for example, NEMA 3R. I know it's a common thing in our industry, and I'm in Texas. So I see people wanting to install their electrical equipment out in NEMA 3R enclosures, and I cringe a little bit because of it, because of the heat concerns. As far as the actual temperature requirements, and you really have to be, it really goes down to what is the maximum temperature in a location, and that varies from West Texas versus, say, Wisconsin. And the maximum temperature rise in the equipment itself. Okay. There's not a pretty clean answer to that, at which point you cut off and it makes sense.
Right. Well, thank you so much, Brant. That is some terrific information. Thank you for those great questions as well. I'd also like to extend a special thank you to our sponsor, Schneider Electric, for sponsoring today's event. And now that we are just about done, we want to hear how we did. An exit survey will pop up on your screen as soon as this webcast ends. Please take a moment to complete it, because we use this information for future webcasts. And finally, on behalf of Consulting Specifying Engineer and CFE Media and Technology, I'd like to thank you for attending. This is now the end of the webcast. Thank you and goodbye.